Well, big thanks to our sponsor, Niagara Conservation. They have some of the lowest flowing toilets that are both affordable but competitive with conventional toilets in the world. Introducing the Stealth 0.8 gallon per flush single flush toilet, and they've got a new dual flush that goes down to 0.5. You really can't get any lower than this without risking major backup. They use vacuum-assisted technology and other innovations and have glowing reviews from affordable housing renovation developers. We have the reviews from developers we work with who only spec this toilet because it's more durable than the conventional toilets and helps reduce the growing water bills that you'll see on your tenant's bills or your own bills across the country. You know, if it works in this situation, it'll certainly work anywhere. The original Stealth now has a durable side handle, innovative and stylish. It adds timeless elements to what is otherwise a very forward-thinking toilet. These toilets can also be fully ADA compliant and ensure the trending integration of accessibility into green building. Bonus, Niagara and AM Conservation have WaterSense certified 1.25 gallon per minute shower heads, 0.5 faucet aerators, 1.5 sink aerators for new and existing buildings. These low-flow devices feel like normal and not only save water, but also save energy through reducing hot water needs. Check them out today. All right, well, I want to welcome everybody to the introduction to the WaterSense Water Budget Tool. This course is approved for 1 hour in continuing education units, and special for this course is AP Homes. I am your moderator today. My name is Brett Little. I'm the Executive Director here at the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. I want to welcome our guest speaker today, Olga from the EPA, that's Environmental Protection Agency. Olga holds a BA in Architecture and Master's in Environmental Engineering. And as an architect and environmental engineer with EPA WaterSense team, she works on the new homes portfolio focusing on WaterSense new home certification, water efficiency in homes, energy efficiency as it relates to water, heating, and distribution. So I want to welcome Olga and let you take it away. Thank you.
Great. Thank you so much, Brett, and thank you to everyone who has joined us. It's great to kick off the fall with this webinar, and I guess also a little difficult to come back from a long weekend. But here we are, continuing our mission. So today we are going to take a deep dive into the Water Budget Tool, which is used for various green certification programs, including LEED and, of course, our WaterSense labeled homes. We're gonna look into both of our tools. Well, it's the same tool, but different formats. So we're gonna look into the web-based format and the Excel-based format and do some quick demonstrations on both. We'll also talk a little bit about the background and the basis for all the calculations behind the tool. And like I said, we'll have a chance to do some demonstrations. And I've also prepared some neat national simulations that we've done to the tool just to showcase how some of these parameters behave throughout the country. And then lastly, as per GHI's request, we will talk briefly about ResNet's new Water Efficiency Rating Index, which is a sister index to the Energy Index, for those of you who are familiar with the HERS. So to get started, and for a little bit of context, the WaterSense New Home Specification defines the criteria that a home must meet in order to earn the WaterSense label. It addresses both indoor water use, outdoor water use, and homeowner education. To meet the specification's landscape design criteria, which is section 4.1.1 of our water home specification, the landscape area, which is what we'll be focusing on today, must be designed using the WaterSense Budget Tool. This tool is what allows users to calculate how much water and the type of landscaping that would accommodate for water efficiency. The tool is a site-specific method for calculating the allowable amount of water that is to be used for the landscape, and then also calculates the design landscape to make sure that it meets its water budget. The budget takes into account the plant types, the plant water needs, irrigation system design, and the applied water that the landscape receives either by irrigation or by precipitation. So all of these factors are taken into account. The tool, in a nutshell, follows three main steps. The first step, the tool calculates the amount of water a standard landscape would require and the amount of water the design landscape is allowed in order to be considered water efficient. So in other words, how does the reference landscape compare to the design landscape? So that's what we do in step one. Next, the tool calculates how much water the design landscape requires based on climate, plant type, and the irrigation system design. And lastly, it determines whether the design landscape meets EPA's criteria. Essentially, we're trying to see if the landscape really is meeting water efficiency standards. And we're going to talk in more detail about each of these steps. So what are some of the major factors that we take into consideration? There are two major climate-based factors, which are water use and performance. So for comparison, through our products labeling side of the program, products in general must use less water while performing as well or as better as the conventional models. So for instance, when we certify or when we label toilets, the requirement is that they become at least 20% more water efficient while still performing just as well as a standard toilet. And so following this model, performance of the landscape can be judged by the presence of healthy plants and, of course, the ability to meet expectations for both how the landscape is functioning and the way that it looks, so all of its aesthetic effects. One thing that is very important is to note is that every plant will have access to the water that it needs. Otherwise, that's going to affect both the aspect of performance and of aesthetics. So we want to make sure that even though we are being water efficient in the landscape, we're still providing enough irrigation so that we have green plants. For the purpose of this specification, it was decided that we would implement this through a performance-based approach compliance, that way allowing more flexibility and ease of meeting the criteria. The allotment approach means that the builder or the landscape professional must put thought into the landscape plan, which ideally will lead to a landscape that has more quote-unquote curb appeal and increases the value of the home, which of course results in both environmental benefits and benefits to the homeowner. For the base or the reference scenario, we chose a well-maintained lawn which is composed entirely of turf grass. So this is what the model compares it to, and then it assumes a 30% reduction in the associated water use. And this is how we calculate the water efficiency. So essentially, a simple lawn with all turf that's at least 30%, that requires at least 30% less water would be considered efficient. This doesn't mean that we believe that the water, that the lawn should only be watered at 70%, but rather that it's using 30% less than what it requires. And we'll explain this concept a little bit further later on. The data that we use to calculate the water use is modeled across the United States by zip code, which results in site-specific allotments. Therefore, while everyone must achieve the same minimum percentage reduction, the actual requirement in terms of gallons of water varies greatly throughout what is appropriate for each region. And we'll see those through the national-based simulations that we prepared at the further into the presentation. And finally, the data are conservative in nature in order to result in a landscape that's capable of withstanding the most challenging months of the year. So though we're wanting to save water, we don't want the landscapes to sort of burn out in the hottest months throughout the summer. So looking into the data, what are the required inputs that the tool functions on? So the two climate-based inputs are rainfall and ET. ET is captured at IWMI. That's where we obtain the national values for ET. And these two climate inputs are local reference for every region. The tool also, of course, considers the type of vegetation and the type of irrigation equipment that is installed. So a little bit more about ET. One of the things that the WaterSense took into consideration in order to make the tool easy to use was to have a standardized set of data that covered the entire country. So while numerous local resources, while we have access to local resources for rainfall data and other sorts of climate data, ET data sources are pretty scarce. So we went to the International Water Management Institute, which is the website that you see here on this slide, and they have a climate atlas that has data ranging from 1961 to 1990 from weather station data across the world, and they model monthly summary data for a number of parameters, including ET in our case. The US data that we extracted was summarized with the average value for each zip code using ArcGIS. And in order to be consistent in both of terms of actual data and the process that we used to model it, we also extracted the precipitation data ranging from 1961 to 1990. And that was taken from the Water Budget Data Finder. And for those of you who use the Excel-based water tool, there's always a link to that to gather that data. What this means in terms of the way that the tool function is that when the user enters a zip code, the Water Budget Data Finder displays the peak watering month associated with the ET and associated rainfall amounts for that zip code. They'll just then use those values provided by the Water Budget Data Finder in the WaterSense Water Budget Tool. We designated the peak watering month to be the month where the ET exceeds precipitation by the greatest amount, simply because this identifies the month during which the landscape would require the most additional irrigation. So for locations where precipitation always exceeds the ET, the peak watering month is the month with the highest ET. So that was a little bit into the weeds about ET, but it's important simply because of the impact that it has throughout the tool calculations. Now to get into the actual equations that we use within the tool, and this basically follows the steps that are taken, the 1, 2, 3 steps that are taken to go through the calculations. So our first equation is for the baseline, where ET is the local reference evapotranspiration, and this is in inches per month. Then we have A, which is the landscape area, and this is calculated in square feet. And finally, we have the conversion factor, and this is so that we can get our results in gallons per month. So in order to have the reference point for water use, we set this baseline, which is based on the amount of water that's required by the site if the landscape area is watered at 100% of the local reference ET. So this refers back to what we explained in regards to the ET values. We just believe that this is a solid standard since ET is representative of the amount of water that's lost from a well-maintained lawn of the average height and the surrounding soil. So basically, we're just trying to set the most standard landscape setting out there. It is important to remember, though, that the EP varies by region, depending on the amount of sun, wind, humidity, and temperature at the specific location. So, for instance, hot, dry, and windy locations have higher ET values than cool, humid locations. The tool uses a database on a 30-year historical averages for all of these variables. So that's for our first step. Our second equation is the landscape water allowance, also LWA. And this is, so we're basically multiplying the baseline, which we obtained from the previous equation, times 70%. And what this equation results in is the amount of supplemental water that's allotted for the designed landscape. So for purposes of the specification of the LWA, 70% of the baselines, the 70% amount of water that would be needed if the entire landscape was covered by a well-maintained, again, average height green grass. The water budget method assumes that all plants will require some amount of supplemental water. We've just assumed that a landscape will have a variety of vegetation that have different water needs. And then for our last, our third equation, this is the landscape water requirement. And all the variables here, we'll go through them quickly. So, so the landscape water requirement for each hydrozone, which we'll explain a little bit later what hydrozones are, is expressed in gallons per month. Then we have our distribution uniformity, which is the lower quarter distribution uniformity. ET being the local reference evapotranspiration value. K, which is the landscape coefficient for the highest water-using plants in the hydrozone. R, which is the allowable rainfall, and we've designated as 25% as being the actual usable rainfall, and C being the conversion factor, so that we could have our results in gallons per month. So this is calculated. This equation allows us to calculate the landscape into hydrozones so that we determine the LWR for each hydrozone and then add all of them together. The separate hydrozones should be calculated for each category of vegetation planted. So we're talking about trees, shrubs, ground covers, and turf grasses. The hydrozones should be calculated within vegetation categories if different types of irrigation equipment are used on the same type of planting. And when we go into doing the demonstration of the tools, we'll see how we have the options of each of the different types of irrigation systems. Like we said earlier, the LWR is based on ET, the landscape coefficient, the area of the hydrozone, and the DU that's associated with the type of irrigation equipment. And again, a portion of the local rainfall that's designated as allowable rainfall, and so that's what we decided as 25%. So that is our final equation. So now we can move on into the actual demonstrations. So first, we're going to go through a demonstration on our Excel-based tool, and then we'll do another demonstration on our web-based tool. So for here, this is what the first page looks like for the Excel-based tool, for those of you who are familiar. In the blue sections are usually the sections that require user input. The yellow sections, the blue sections are all basically default project information. The yellow sections are reference information, and gray sections, which we'll see in the next slide, are meant for input. And so this tool, one nice thing about this tool in comparison to the web tool is that you sort of you get the opportunity to see the background information behind the tool and sort of understand the more technical aspects of it, which is kind of nice. Then you move on into the gray area where it's going to require all of the inputs. So for step one, we're entering the landscape area in square foot. So for the sake of the demonstration, we're working with a landscape of 5,100 square feet. Then we enter the average monthly reference ET, which in this case is 6.25. Within the tool, you'll find the link that will take you to the database where you can obtain that based on your location. And then these are the results of that calculation. So this is essentially our baseline. It's that first equation that we talked about. So based on the output, we have 19,869 gallons per month that would be needed for this site. And then our water allowance for this site is 13,908. And like it says here, it's based on the site's peak watering month. So this is the hottest month of the year. Then we move on to step two, where you find where we're going to go ahead and calculate for our LWR, again, based on our peak watering month. And so the first entry that you make is enter the average monthly rainfall of the site. And again, the link is provided where you can obtain those data points. It's 1.68 for this specific site. And then it takes you to then our, the second part of the second step is to include all the different hydrozones that make up the entire landscape. So essentially you're breaking up, in this area, you're breaking up the square footage based on the type of landscaping that you have, and of course, this number needs to equal your original landscape number that you put up in step number one. So here you have the opportunity to break it down. So in this case, we have 2,438 square feet of turf grass with medium water requirements. The landscape coefficient for this is 0.7. The irrigation type is a fixed spray. The DU is 65%, and so it calculates the LWR for each specific hydrozone. And so it continues to go down. We have a mixture of shrubs with low water requirements. Its K values, all of the shrubs have been assigned drip standard irrigation with DUs of 70%. And as you see, their LWR values. And finally, this is sort of our backyard. So 450 square feet of ground cover with low water needs at a 0.2 coefficient, also with drip irrigation, 70% DU, and then finally our turf grass. So like I said earlier, we calculate all of these totals and then obtain one whole number for the landscape water requirement for the entire landscape. And then we move on to, I'm sorry, this is actually, before we get our results, you'll also have access, and this is only in the Excel version of our tool, you have access to all of the tables and charts that sort of break down what are the values that you're inputting in the previous table. So based on plant type, you find your K values. Based on irrigation type, you find your DU values, and then sort of a reference table showing you the appropriate irrigation types for those areas that actually have irrigation systems. And then based on all of those inputs, we get here our water requirement for the site, which is 13,907 gallons per month. And then in step 3 is basically our summary of all of the calculations that we've put in. So our LWA is 13,908 versus our LWR, which is 13,907. And based on this, you'll see here, it'll automatically tell you whether we have met the criteria for water efficiency or not. And so in this case, it has been met. So that's a little bit of a quick overview of how the Excel worksheet works. And now we'll look at the web-based water tool, which essentially is the same as our Excel. It's based on our Excel sheet. It just has a different interface and can be found on our both tools can be found on our website. The Excel sheet can be downloaded from our website, and this one, it's basically live, and so you just you can just work on it. One caveat about our tool is that if you do have, or if you're trying to work through different iterations of landscaping, we don't have anywhere to save it or keep it in store for you. So you could either, and we'll see this on step 3, you could either print out PDF formats of reports for each iteration, or what I do is take screenshots until we decide what landscape combination we're going to go with. We are aware that this is something that our users have sort of asked us for. We recently updated our website and are currently undergoing a revision for our home specifications. So the tool is really something that we haven't wanted to invest many resources into, mainly because we know there's going to be changes in the program in general. So we are aware of it, and we should be doing something about it in the future. So when you come to the website, this is the first screen that you come upon. The inputs that are requested are for what purpose the tool is being used. For this instance, I chose WaterSense labeled home. There's also the option to do LEED, existing home, or other, just through that pull-down menu. It also asks you how many sites. So in case you're a developer or a commercial builder, you can calculate this for more than one building or home. And then it asks you if you have an irrigation system, yes or no. It asks you for the zip code and the total square footage of your landscaping. So in this case, we chose a zip code in South Florida, and we have a square footage of 4,200 square feet. Then you're able to go hit next, and rather than having to find all the values yourself from those tables that we saw on the Excel sheet, you're able to simply do the inputs in here, and the tool calculates all of these values for you. So in our case, we have 2,438 square feet of turf grass, which is usually our most demanding type of landscaping application. Water demand chosen as medium. Like we said in the first step, there is no irrigation, so the tool calculates the impact that's going to have on water use and the required water. So for the turf grass in this case, it's 9,674 gallons per month. Then we have two types of shrubs, one area that's 588 square feet, another area that's 392. Both of them are classified as low requirements for or water demands. Then we have our required water for each, 428 gallons per month and 286 respectively. And finally, we have two areas of ground covers, one at 350 square feet, which requires low water demand, and the water requirement for this is 255 gallons, versus this ground cover, which has a medium water demand, and so the required water is quite a bit higher at 1,164. And then at the bottom, you see basically a summary. So this essentially calculates that you are using all of the area that you claimed in step one. Then you're able to see your water allowance, which in this case is about 12,000 gallons per month for the entire landscape, versus the actual water requirement for the site, which is 11,807. And so in this case, we meet the requirements for water efficiency, and we're able to go to the next step. I went ahead and switched up some of the criteria up on the table, just see what would happen if we were to use landscaping applications that would demand more water. So in this case, the only thing we switched was we changed this from ground cover over to turf grass, which usually requires more water. And so as you see, there was an impact as to our water efficiency. We're no longer meeting the criteria that's required. And if you compare the water allowance versus the water requirements, you can see that it is higher. And so in this case, we're not able to move over to the next step, which is where you're able to obtain your report. In the first scenario where we did meet the criteria, this is the next step or the next screen that you see in step 3, where it gives you a summary and then allows you to input your information to obtain a report on your calculations. So that is a pretty quick overview of our web-based tool, which is pretty simple, besides the little caveats that I mentioned earlier, but basically give you a good overview. And so moving on, this is just more to give everyone sort of a general feel of how the tool functions throughout the country. We have set up a few scenarios with different variables to just test out and see how the same sort of criteria would apply throughout different regions of the country. So this model assumes a landscape area of about 6,140 square feet. It has 100% vegetative cover, so there's no softscape. And there are only two categories of plant types that we're considering, which as you see are defined by the coefficients and the DU values. All the turf grass is not irrigated, and the ones that are irrigated are with a fixed spray, which is why you see that the DU is 0.65 for all of them. So these values, what they mean, the K coefficient for turf grass is for the type of turf grass that's being used. The DU is the distribution uniformity for the turf grass that's being used. Then this K value is for the shrubs, trees, and ground covers, essentially anything that's not the turf grass. And then the same, the distribution uniformity for those other ones. And so what we did is we set up 24 different scenarios. No, not to worry, we're not going to go through all 24 here, but I just picked some just to showcase the difference when we start moving these variables around. So for scenario 1, which was actually our most efficient scenario, we used a plant type of low watering turf, irrigation of a fixed spray, And then for the other types of vegetation, also low watering and the irrigation system being a pressure compensated drip. The values that we applied for these were 0.6 and 0.65 for the turf grass, 0.2 and 0.9 for all the other vegetation. And as you can see, what this legend shows is the greener areas showcase how much of the regions are able to be turf grass while still maintaining water efficiency, and the redder zones are the least water efficient. So as you see, based on all of these values, most of the country is still able to be pretty water efficient throughout. We started to get into the area of 50 to 59% of turf coverage, which still isn't that bad. I mean, people are still able to have their green lawns for the most part in a scenario of this sense. Like I said, this scenario proved to be our most efficient. Then we have scenario number 17, where we switched up the values. So for the turf grass, 0.8 and 0.65, and the other vegetation to be 0.2 and 0.9. And here we start to use high water demand turf, but still keeping low water demand shrubbery. But already with just switching up the turf water demand, you start to see the impact throughout the regions. Of course, our West Coast always tends to be the most impacted by weather and other climate impacts. And so the map starts to look a little bit less greener and a little bit more in the warmer tones. Then in this scenario, we start to see turf having a little bit of a harder time when we use high demand water turf and then medium demand vegetation. Again, the West Coast looks the harshest, getting into the 20% region. But if you notice, you still get to see some green out in like the Alaska, Hawaii regions. And some are little pockets in here in this northeastern. And now we really start to get into the red zones when we start using really high water demand turf and high water demand vegetation, and still using the pressure compensated drip. But like you notice, our values for the turf have really fluctuated here. And so now we have more than half of the country in the 0 to 10% allowance for turf in order to stay efficient. And then have a couple more extreme examples. So this scenario 21, for instance, ranked as our ranked 11th on the water efficiency scale comparison. And then here, this is our very lowest efficient scenario where we're using high water demand turf with a fixed spray, and then high water demand vegetation, trees in this case, and their irrigation being a standard drip or micro spray type setup. And so here it's really taking a toll on the water use. Some interesting insights that we did find from sort of working through these scenarios was that there is no place for instance, if we go back to scenario 1, there's really no place in the country that can't achieve at least 60% turf in scenario 1 or 2 while still maintaining some efficiency. So that's a really sort of positive outcome from this exercise. just realizing that our requirements really aren't that strict, and it really is possible if we use the right type of mix both between landscaping and irrigation systems. Another observation was that over 35% of the country can actually achieve more than 90% in scenarios 1 and 2. So if we were to be really efficient throughout the country, I mean, 90% proves to be a pretty good number. And then in the mid-ranging scenario, so something like this, that might be a little bit too extreme, but something like scenario 19, where we have high water demand turf and medium demand vegetation, a mixture of trees, shrubs, and ground covers, we see that about 33% of the country could achieve more than 40% turf. So that's still pretty good. So we really don't want people to believe that we don't want turf to be installed, or that we think it's a bad idea, but rather, you know, using it in a sense that can still reach some water efficiency standards. And in our most extreme case, I thought this was fun. So scenario 24, where most of the country is basically red, we found that even then, at least 0.14% of the country can achieve 100% turf. And of course, this is all just in Alaska and the Hawaii region. So, I mean, that's still a little bit positive, gives us some hope that even in the worst case scenario, we can still have some areas that are water efficient. So that was it for the scenarios. Before I jump into the water efficiency rating index, Brett, I'm going to ask you if you wanted to sort of tie in the previous information into LEED, or if you'd like me to just go into this.
Why don't we, there are some questions about the tool. Do you think we can quick go through some of those, and then we'll wrap up?
Absolutely.
Great. So can you just speak real briefly about how this could be used, or can it be used in regards to multifamily or even commercial building landscape plans?
Yeah, absolutely. So even within the tool, and you guys will have to forgive me, I always sort of gravitate to the web-based tool, mostly because of it just tends to be more user-friendly. But if you are doing multifamily, you do have the option here of whether this is a single site or if you have various sites. I guess in this case, if you're doing multifamily in terms of a high-rise, that would be treated as a single site, just because it's all sort of in one place. But if you're doing multifamily as far as like a community or, yeah, sort of like a gated community, single-family homes, then this is when you would choose the development of multiple landscapes in this area. And then as far as for commercial sites, though we don't have a certification program or a specification that focuses specifically on commercial, I really don't see, I mean, as far as using it as reference and as a resource, yeah, I mean, it would still apply, mostly because, like I mentioned earlier, it's based on zip code, and so you will be able to pull from the data based on where your site is, regardless of what type of building you're working on.
Great, thank you. Can you explain briefly why, if a certain vegetative section, I'm saying that term wrong, but a certain section of vegetation does not have irrigation, why it even needs to be counted in the tool?
So let me see if I understood the question. So why a specific section of landscaping that doesn't have an irrigation system needs to be included?
Correct.
Well, if it doesn't have an irrigation system, it doesn't necessarily mean that it doesn't need water. And so therefore, it's still part of the landscaping. And I guess I'm not sure if I'm answering that question right, because I'm not sure if I understand it. But we're assuming that if it's part of if it's included in the landscaping area, then it's some sort of vegetated species that will need some amount of water, whether it's low, medium, or high.
Is it safe to assume we get a lot of people who are not installing irrigation. So is it just safe to assume that they're, like you said, they're going to be then using the hose, right? Which is fairly, I assume, very inefficient.
Right, exactly. And so that's one of the, I guess, caveats of this whole exercise is that we really can't account for human behavior. And so really when the tool really serves as a reference point as to how much water should you be using. Because, yeah, I mean, if I'm out there in the yard with my hose and I'm talking to my neighbor, I have no idea how many gallons are coming out. So, so it's not to say that the tool doesn't account for that, but yeah, it's still assumed that given a specific type of vegetation, there will be some type of water use.
Yeah. And then we're going to have time for more questions, but last one before we move on here. What about those who are outside of the U.S.? What can they utilize this tool and find the ETO values?
Yeah, so that's definitely a tricky one. The ET values from the resource that we have, they do have other parts of the world, or the regions of the world, where you can obtain that. The tricky part in doing international calculations is whether there's access to rainfall data and other types of climate data. What I have found to be useful in that case is to find a region within the United States that has similar qualities to any international location you might be looking at, and then trying to find a similar comparison in that sense so that you can sort of work from that. And so, of course, it's not going to be an exact calculation, but it will, give you a better idea.
Got it. Thanks. So let's move on, and then we will have time for more questions.
Excellent. So let's jump ahead for the WAR index. So the WAR index, for those of you who are familiar with ResNet, comes as an effort to start incorporating water efficiency to some of these rating efforts. So a lot of us that are involved in the construction industry, the building industry, know that HERS is sort of like a guiding force in efficiency, which provides a sort of baseline or I'm using air quotes, grade, for how efficient a building can be in energy terms. And so there was really an opportunity to kind of dive with the same mentality into water and start to create a database, and B, sort of start to populate a comparison of how efficient can buildings actually be. So the index really focuses in comparison to the water tool that focuses mainly on the outdoors. The index does incorporate indoor water use and outdoor. And so in this slide, we've noted some of the things that the index or the steps that have been taken for the development of the index, which is really in its infancy right now. And so it looks into domestic hot water use. It looks into indoor and outdoor water use calculations, factors in new technologies, so products that are water efficient, shower heads, toilets, faucets, things of that nature. It does set up a reference home, and then just like hers, it requires field verification. So this is something that would be done by raters. Some of the objectives when the WAR index was being developed was that it would be applicable nationwide, that would be suitable for both new and existing homes. Again, that it would take into account indoor and outdoor water efficiency, and that it would be practical and affordable to administer. And of course that we could obtain sort of a quantitative comparison based on other buildings alike throughout the nation. So this is something that really hasn't been out in the industry, and it's ResNet's first take on implementing it or putting it out there. And so it's due to come out, or I guess it was out for public comment earlier this year, and I believe the final version should be out by the end of 2017. So we're pretty excited about that. The way that it was developed is ResNet brought together a committee, an interdisciplinary committee, 13 members, 3 co-chairs, including a builder, a policy analyst, and EPA, and then that committee was broken up into task forces that looked into the modeling and the development of the reference home, so what these homes would be compared to, a different committee that focused mainly on indoor water use, another that focused on outdoor water use. And so these committees really sort of dug into how each of these should be calculated. And a group that looked into the rating and inspection procedures. So how is it that we're going to decide whether a building is water efficient or not? And then, of course, how are professionals going to sort of buy into this process? For the reference home, these are some of the factors that were included, and a lot of this was modeled after HERS, which is the energy version of the efficiency or the rating score. So some of the factors that were taken into account were size and location of the home, the average flow rate of all the fixtures, average flush volume of toilets, and all the appliance information. So whether the appliances were Energy Star or not. And then for the outdoor, because outdoor is such a complex area to try to calculate, we went ahead and used the reuse report, which is kind of our most up-to-date outdoor use data available, and incorporated the size and location of the landscape, an automatic irrigation system, and then whether there was the presence of a pool or not. And really the pool is because of its because it has such a high rate of EP that it really needed to be incorporated into the reference home. And within the reference home, we believe that both the indoor and the outdoor models provide good statistics background, and they're both representative of the current construction practices. This is just some of the resources that we use to gather our data. So this is from the residential end uses of water study that I mentioned earlier. The original report had been published in 1999, and then there was an update which was published in 2016. So that update really helped with the development of the index. And essentially what the index says is that we're comparing the rated home versus the reference home and multiplying it times 100 to basically provide us with a score. So anything lower or closer to 0 is the most efficient. Anything above 100 is using more water than needed. And then this is just to compare, to see how it compares with the HERS rating system. And it was important, one of the most important parts of the development is that this rating index would work well in collaboration with the HERS index. That's kind of it in a nutshell. So I'll let you go ahead and loop in with LEED, Brett.
Great, thanks, Olga. And just to be quick, can anybody who's interested participate in any more public comment on the WERS or any more opportunities coming up? Should they go somewhere to get involved?
Yeah, you can definitely go to the ResNet webpage. They always make announcements about when they're opening for public comments. I believe the first round is already closed, but I think later in the year they will be open. I know ICC has also set up a committee, and I'm sure that they'll be putting out requests for comments from their end.
Great, thanks. So just to wrap up here, the water budget tool is a potential major part of the new LEED for Homes version 4 rating system. Just to give you some background, the 2008 version used a sort of, what I'll say, very clunky version of the WaterSense budget tool before it existed. You had to have a landscape master's architect or someone who's been in the field for 10 years come and verify your project, come up with all of the different calculations, the EPO, you know, the local precipitation and all that. And they had to fill it all in, and then that had to get submitted to USCBC a month early before you could even finalize the project. And so as you can imagine, a lot of people forgot about that, and we still have them coming in during the final certification stage. And so you know, a lot of things just simply get you know, get missed, and it's been a whole debacle in my experience. So we're very excited to see LEED move on from that and incorporate the water budget tool into version 4 and do it through the water efficiency performance pathway. Now, one of the reasons you might want to use the performance pathway, as you can see up there, versus the prescriptive is, number one, you're trying to go for advanced water conservation or advanced water efficiency, both indoor and outdoors. So if you're trying to get really all the points, anything above 8 points, you really got to go for the water performance pathway. Number two, we see this situation once in a while where, let's just take this example. You've got a low-income housing development, and you know, they definitely just are very nervous about low-flow toilets, or you've got a really high-end house and they just need to have those high-flow shower heads. Well, in that case, you got to make up that water reduction somewhere else. So you could theoretically make that reduction up with a better landscape design in both of those situations and reduce water there. And there you can still have your, you know, have your cake and eat it too. You can have your high-flow device inside, and you can make up the reduction one way or another. So that's one of the benefits. Those are the two reasons you probably want to take that performance pathway. So heading over here, water reduction calculator. Over on the right side, you'll see there's the tabs we were in on the bottom, WE, and then water reduction calculator. The two key areas you're going to be focused on: the baseline for the site, gallons at peak month, and then the landscape water requirements. Those are going to be your areas that you're going to be focused on, you know, for this particular program for the landscaping side of things. So I kind of just took Olga's version here, the one that failed actually, but just to kind of show a point, you can see we took the 1235 total water requirements and put it down here in the baseline, and we took the 12168 and put it down in the gallons peak per month for the landscape water requirements. So you can just see once those outputs come out, you can match them up right here. And then you can see what that does is if you scroll down to the bottom, you can see that here is your indoor or your outdoor water savings. We didn't do indoor for the sake of this webinar. And you can see it's 1.53%. So even though it failed, it does add to that overall reduction. So so we're not looking for, LEED isn't looking for you to meet WaterSense by any means, but obviously if you don't meet WaterSense, it'll be very difficult to get points unless you're taking a lot of those points from indoors. So this is just a quick example of water budget tool is required if you're taking the performance pathway, and then statistically how it fits into the overall 20 through 70% reductions that you need in water usage to score in the performance pathway. I will say this too with LEED. We've had a few project teams that were using the online form, but they went through 10, 20 iterations of the landscape plan. And when I showed them the Excel form, they were like, wow, this is I didn't know this existed. So definitely get that Excel form, get really early engaged with the landscape design professional. If you can get engaged, just like energy modeling, you want to do water modeling really early to help your clients save money and to maximize the most points. Don't think of it as an afterthought where you try to come in and then fit it in later at the end. It's going to make it very difficult and may compromise your certification. Get that Excel format, create these, and make change iterations. That's what it's there for. There's no, there's no cost to it. And then on the LEED side, I do see a question here, and Jennifer, I think you're referring to a little blip that's on page 135 on the LEED for Homes manual. And in that manual, it says that the budget tool may indicate that a non-irrigated zone will use 0 gallons of water. If this is the case, then do calculations for both, but they said don't use zones that indicate 0 gallons of water. So that basically you do have to put in LEED, I do want to make this clear, you do have to put in non-irrigated zones for LEED. You can't circumvent them. But it says something about if that zone comes back with 0 demand, then you can exclude that. You can exclude that zone. Olga, is that maybe an old issue with the tool, or is that something that does happen from time to time? You still with us, Olga?
Oh, I'm sorry. I was muted and talking. Yeah, it is something that happens from time to time. Okay.
So yeah, it sounds like LEED just wants us to throw those out. So I guess that's the way you have to go on those projects. So thanks. And then finally, for those of you doing Green Star certification, the WaterSense Water Budget Tool is built right into that, and you can drive your points down from 10 to 100% savings using that tool. And if you don't irrigate, then definitely you can still use that tool as well to accrue your points. So that's it. We definitely got a little bit more time for questions. I want to thank everybody for joining us here, and I know right off the bat I have a question to kind of get things going while we have a second. And actually, before we get to those questions, I wanted to just real quick thank all of our sponsors: Sun Intuitive Self-Tinting Glass, the CERV by Build Equinox, GeoComfort Geothermal Systems, Niagara Conservation, Panasonic Ventilation, and Certainteed Air Renew, formaldehyde eating drywall. We couldn't do it without them, without our members, our board of directors, or all of our volunteers. And then real quick, for those of you looking for your CEUs, make sure to take that survey, report your GBCI, we'll report your AIA, and for those of you watching on demand, make sure to take that 10-question quiz with an 80% passing rate. So here's a question. Yeah, could you explain how to enter an area which includes trees over shaded turf? Is there a different way that we can count this?
So the quick answer is no. No, and the logic besides that is that we're looking, so if you have the tree, we're taking into consideration the tree canopy, and assuming that the tree is going to be needing more water than the turf underneath it.
Great, thanks. I'm forgetting what my specific question was now all of a sudden. So we do have some time for some more as I'm thinking about what that is. Well, I don't see any more questions. I think we had a pretty good dialogue here. So just real quick, Olga, where can, oh, here we go. Let's do one last one here. Are there any guidelines for plant types we can reference which can reduce our water budget, especially for homes?
Oh, yes. There are. You can find them all on our website. We have long list based in region. You're welcome to email me or contact the WaterSense line if you can find them on our website. But yes, there's definitely plenty of resources to give you some guidance on that.
Oh, and then for those who are trying to calculate rainwater catchment, either for stormwater mitigation or for actually catching it and using it to irrigate or drink, is there any ways that the WaterSense budget tool can either help them now or maybe in the future?
Yeah, so right now we're not considering, unfortunately, any reuse or sort of green infrastructure type applications. It is something, like I mentioned earlier, we're in the process of doing a big rehaul to our certification process. So it is something that we are considering. As many of you may know, there are other sort of growing pains to some of these more progressive applications. So yeah, so for right now, it does not take into consideration, so you don't get any credit for any of this, but it is on the table and it is being considered.
Mm-hmm. I will say on a project we just completed for LEED, we used the water efficiency rating score, or WERS with an S, and we were able to calculate rainwater catchment for rain barrel usage and put that right into the LEED checklist. But that was just a minor part. LEED, I know, doesn't accept that tool other than just, it seems to be they're pretty open source for catching rainwater or gray water. So we were able to use that one.
Okay.
Yeah. And what is the, just real quick, what is the EPA on the overhaul?
What is the EPA on the overhaul?
Yeah.
You're talking to a federal employee, so yeah, TBD.
Yeah, sure. All right. That is, I think that's the end of all of our questions here. But Olga, just real quick, where can people, go to find more information if they have more questions?
Yeah, so up on the last slide, we have a helpline. They're very helpful. Anything that you may need from some guidance on resources to how to troubleshoot the tool, you can always give them a call. I can always make myself available. Also, my email, cano.olga@epa.gov. We're always happy to engage with the public. And then our website, epa.gov/WaterSense is always a great resource for both outdoor and indoor.
All right, Olga, well, thank you for your time. Thank all of you for joining us today. Make sure to catch us at the next session. Take care.
Excellent. Thank you all. Bye-bye.